In the previous video, we finished the animation for all the fish, but I noticed that I didn't really like how the way the fish appear and disappear from this whole thing. So I add some secondary animation to it. So let's get started. The idea I'm having is I want when the fish comes into this thing, I want it to gradually appear. And then when it goes out of this thing from the left side, I want it to be gradually disappear as well. And maybe some of the little cube volumes, we can make a particle sim out of it. So let's go to the part where we have all the box volume points ready. Let's hide all the objects. So now we don't really need the color. Let's just put a white color on it. So if we want this thing to gradually appear or disappear, let's put a point blob here. And let's call this a ramp blob. So we can certainly just go here and put a relative to bounding box. First file, current position, and you can plug the, put a vector to flow, and then just grab the X. And now let's put a preview node. So what I like to do is I like to put a rainbow node here. And you can just plug this one into U, and then put this into color. But to be honest, this is very boring. If you just have this to be, a whole chunk of this disappears, it's really boring. So let's actually grab the rest position as well. So sort of get attribute, first file, point number, rest position, and let's put a anti-alias float noise on it. And then let's just like how we do it usually, promote these. And then again, it's going to be a -1 to 1. So let's just fit range -1 to 1. And here, let's put a ramp parameter and plug this in. And let's just call this noise ramp. Okay, and then let's do a fit again. And then let's promote these to the destination. So this one, let's call this minimum offset. Offset. And then maximum offset. Max offset. All right. So let's just, before we plug this into the rainbow, let's just add this on top. And then let's put a parameter here. Here, let's just call this ramp. Export when input is connected, invisible, and plug the add into this. All right, so this is not doing anything. The reason is because this noise ramp, currently it's 0. So we just go outside and start copy, paste relative reference. Let's put a 10 here. And then the amplitude, that's fine, roughness. All right, and then let's put the maximum offset, copy parameter, paste relative reference, and then just put a negative here. So we don't want this high. We just want something like this. All right, so if you want to see like how, so basically what we're gonna do is we're gonna animate one threshold value in the chop net, and then we're going to use that value to determine, if the value is larger or smaller, we're going to delete the point, something like that. So let's put a network here let's put some nodes here to preview how it's going to look like. So let's just put a node here. And then let's put a split node. So let's put some parameter on top of this. Let's do edit parameter interface. And then let's put a separator here. And then let's put a float here. So this one, we're going to call this threshold. Label threshold. And the range, we're going to do 0 to 1. All right. So here, let's do group, ramp, attribute, smaller than, let's just do copy, paste relative reference. And it's not a string. So let's just put it back. And then here, we're going to put points and then invert selection. All right. So when you scrub this, you can see that it's doing something that we want now. And now let's put the null node here. So the first one is gonna be called keep, and the next one, so this is not really. So we're gonna keep doing something here. So even though we kind of delete some of the stuff, but my idea was I still want the points that's sitting right at the threshold to be capped and probably highlighted, and then probably use them as a source to emit particles, things like that. So let's copy this node here. And then let's go to the edit parameter interface. And let's add another float. This time we're going to call this tolerance. So tolerance. All right. So for now, let's uncheck the inverse selection, and then let's just put something like 0.075. And then what we're going to do is this wrap is going to be greater than threshold minus, let's just copy and paste relative reference. We don't need this. All right. And now, so this is the edge. And then again, we want the threshold to stay consistent. So let's just copy parameter and paste relative reference. And then if you scrub this, actually let's color this. So first of all, let's put a null here and then call this edge. And let's put a color here. And let's just make like a really bright pink. And then this is the part that we are really gonna delete. So this is gonna be called delete. All right, so if you merge these two, and then let's just, you can see that when you animate the threshold, okay, something like this. All right, so I kind of like how it looks like. So there's one thing you wanna keep in mind is, so this animation here from 0 to 1, so this is basically what we're gonna see when the fish is swimming outside of the frame. So it's gradually disappear. But then if this is the animation of how the fish is entering the section, then what you want is you want this delete to be the keep and the keep to be deleted. So just keep that in mind when we build up the curves. So let's go back to the ChopNet here. So the plan is at the beginning and at the end of the animation, the fish is gonna come inside and outside. So let's put some parameter here. So let's go to edit parameter interface. So first of all, let's put an integer there. So I'm gonna put this one called anim end. And this is let's just call this a reveal anim end. And then we're gonna put another integer here. This is gonna be called anim length, and label reveal anim length. So here we're gonna put 1170, which is the length of the animation that I chopped outside somewhere here. And then we kind of want, let's say, 24 frames. So it takes 24 frames for the fish to be deleted completely or appear completely. So let's go inside the ChopNet and let's go to the motion effects view. So you can start from these two or this, doesn't really matter because we're gonna change all the values anyway. So I'm just gonna start with the ramp here. So let's work on the start of the animation. Let's put an expression here. And then actually let's grab the frame from outside. So let's put a parameter to end channels, edit interface. Here, let's put an integer here. And then let's put a separator. So this one, let's just call this anim length. Anim length. All right. And then, so let's just copy the anim length here. Paste relative reference. Okay, so under the expression, what we're gonna do is let's do a fit current index, which is basically current frame, f start plus let's copy parameter, paste relative reference, and then 1 and 0. Right. So we get this kind of ramp here. And now let's, okay, actually let's turn on the frame indicator. And now let's work on the end of the animation. So let's just copy that. And so let's kill this one. And then let's grab the anim end inside as well. So let's do integer anim end. So let's go outside and just copy, paste relative reference. So here, let's, so still it's fit indexed, current index number. And then we're gonna fit from, let's copy the anim end. And then it's gonna be anim end minus the anim length, and then 1 to 0. All right, but then we kind of want to merge these two together because if you can see that this is something like this, and so we want to merge these two ramp together. So what we can do is let's just put a current value plus that, so we get something like this. And another thing I noticed is because the fish is the ramp is 0 to 1, so current value we have right now is 0 to 1. It's going to leave a little bit, just the tiny little bits of the head or the tail not deleted. So let's put a fit, put an expression here and use the fit again. Let's go to value here. So because this is going to be a fit 0 to 1, and let's put a negative 0.2 to 1.2. So just to be safe, this way all the stuff is going to be deleted. And now let's rename this channel here. So currently it's called ramp 0. So let's just rename it to, let's call this reveal star. And let's just merge that to the merge. And then we can grab this value from the channel now. So outside the network here, the attribute create, we need to add the reveal here. And then under the channel atom, so let's just put reveal, reveal. All right, so it's gonna have the So let's hide all attributes and then turn on the review. All right, so you see that this is doing something for us. Okay, now let's go back to where we did all the ramp stuff. So because when we were testing this thing, because the start at the and the end animation, it's slightly different. So let's actually divide this case into two parts. So let's put a switch here. Sorry, switch. So let's put a point wrangle here. And let's add a attribute. I reveal equals to 1. And then let's plug a second one here and plug this into switch. And this one we're going to call it reveal equals to 0. And here the condition, let's put $FF smaller or equal to 1050. All right, and then let's put another point wrangle here. So here we're gonna do ramp is equals to 1 minus ramp. Okay. So when it is the beginning of the animation, which is less than 1055, we're gonna, so when the fish enters the frame, we're gonna reverse the ramp, and then we have an attribute reveal, it's 0. And then when it's the end of the animation, the reveal is gonna be 1. And now let's put some group expression here. So let's drop a group expression. Again, we're gonna go to the edit parameter interface. And let's just put 2 float there. And then put a separator there. So the first one is gonna be called threshold. And the second one is gonna be called tolerance. And then, so the threshold, we're gonna grab the value we just made from the ChopNet. So let's do point, channel, anim, the first point, reveal, first digits, right? And then threshold is gonna be 0.075. And then the group type is gonna be points. So let's create the delete group first. So the delete group is gonna be ramp value is less than, let's just copy threshold, paste relative reference, and we don't need the backtick. And then let's create another group. This is gonna be called edge. So the edge is gonna be ramp value is larger than, let's copy this, minus, let's copy this and paste relative reference. Again, we don't need the backtick and the string. So I wanted to see that how these groups look like. So let's just put a last note here. So the part we're gonna keep is we're gonna delete the delete group and the edge group. And the part that we're gonna color as edge should be, let's just put another blast. Oh, blast. And then let's call this edge, points, delete none selected. And then let's just color that as pink. All right, and then let's just merge these two. So because I only, the edge should be between those two, but here I only did part of it. So let's put another group combine node. So the group combine node here, let's put the edge, sorry, point and the edge group. It should be the current edge group intersect with the delete group, like that. And then the delete group, let's put another group combine here. Points. So the delete group should be the current delete group subtract the edge group. Okay, so now if you look at this, all right, it's doing correctly at the end of the animation. That's right. And then if we look at the beginning here, okay, that's correct as well. So when we render this thing, what I'm going to do is, so here I already have the animation copy paste. You want to plug this in the stream, and then after you cache out all the fish points, so before you generate a volume, so what I'm going to do is, so let's say when we are somewhere around here. Okay, we have 2 fish. All right, so I'm gonna put a split here, and then I'm gonna put a points. So let's put delete and add here, and let's do invert selection. Maybe something like. Hold on. Right. Okay. So here you can see that it's getting rid of the delete and edge, and then you can plug this thing into the VDB from points, from particles. So when we convert this to the volume, you can certainly render 4 fish together in one render, but I find that it's not very efficient, because the thing is the voxel size is pretty tiny for this setting here. And this is a pretty high resolution volume. So since we already have this fish ID set up, what I would do is I would actually split it into 4 fish and render them separately, so that you don't have to waste your resources to generate the volumes in between. That's going to be a really big waste, to be honest. And then, so the second output of the split here, which is the, so what I'm going to do is, so I'm going to put another split node here. And then here I'm going to do edge. And I'm going to just put a null node here. So this is the edge group, and I will actually convert this to a VDB and then just render this as a separate render as well. And you can combine the 4 fish together, because there are no cases that there are 2 clusters of points appearing in the screen at the same time. So you can just combine them and render them as one render. And then after you're happy with this section, all the stuff we did, all the chops, the groups, the ramp, everything, you can just copy, paste them, and move them here to the fish contours we did. So one thing you want to be careful about is, because we did 4 fish, and these points, when you render it, they need velocity blur. So make sure that you want to do something like this. So you want to use the ID to just add the fish ID on top. And then you can use the trail node to compute the velocity of these points, and then when you go outside, and if you go to the render node here, so let's go outside and go to the contours. So here, under the sampling here, you want to put velocity blur on it. And the contours, you can render them all as one render. Just the volumes of the different boxes, you want to render them separately. Now let's continue and work on the secondary animation of the fish in the next video. In the last video, we added the animation of the fish going in and going outside of the section here. So let's continue and work on another animation that I wanted to add it here. So whenever the fish is doing this pulsing animation, I want the body to have like a light area traveling along to the tail section. So let's see what we can do. So let's go back to the chop network and let's turn on the motion effects view. So we can basically start from here. This is the first trigger and this is the second trigger. So let's just copy the second trigger here, and we can use this to as a starting point. So here, depends on what you like. You can change the attack length to, let's say, 36. So delete, and then say something like this. So the pulsing, the light travels to the whole body. The whole process is going to be a lot shorter. But for now, let me just bring it back. Let's just keep this for now. And there is one problem, which is when the value of this curve here, when the reveal is that the value goes from 1 to 0, which means the fish is going in and outside of the frame. And you don't want the light to kind of overlap with that, because that way you get just, it's just too much stuff going on. So we need to do something here. So what I'm going to do is I'm going to put a expression here. And then I'm going to plug the... So remember, we actually did a fit 0, 1 here. So we're going to pick the one above it. So let's write something here. So if the incoming channel 1, which means the second input, which is the reveal animation, and 0, because there's only one channel here, and then $i, the current index. If the current index is more than like a very tiny value above 0, then we're gonna kill the trigger. Something like that. So if you bypass this one, you can see that, so this is something we get. So it's gonna kill all these, so that when you trigger the whole thing, it's gonna happen after. And you can't really put this thing behind the trigger, after the trigger, because you have to kill it from the starting point. All right, and now I'm just gonna copy the same lookup animation we had earlier. Plug that in. So it's same curve. And now let's just rename this. So currently it's called ramp 0 anim. So called ramp anim. And so let's just call this ramp for now, because we use the ramp, but we never export it. We might as well just use it for this case. All right. So let's go outside, and because we already have the ramp here, so all we need to do is let's just put ramp, ramp. Okay. And now let's go back to, so this is where we set up the group. Let me actually just pull these stuff down here. Now let me put another null here. So let's put a group expression. Oh, actually, let's just copy this one here, the one we had earlier. And let's just kill these two. So here, let's call this bright. So the threshold. So the threshold here, let's change this to the ramp value because we don't need the reveal anymore. So here, let's write some expression here. So we're gonna do ramp is bigger than, larger than the, let me just copy this. This relative reference, and we don't need this. And then minus the threshold, place relative reference. And then we need an end. And this needs to be smaller than the threshold as well. Okay. And we can drop a color node. Let's just color the right group. Okay. So you can see that so it's traveling along the body. Was the animation at the same time. So there's one more thing I wanted to add here is when the color travels along the fish body, I want the value of this to decrease gradually as well. So we not only need a group, we also need a fade off. So let's go back to the chop network. And the only thing I did really was just, because we already have this decay here, and it's all fine, but so I just copy the rename node and I plug this directly without the filter node, and I just rename this decay intensity. And just plug this in the merge node. And then I'm going to go outside and grab the decay intensity. Here, decay intensity. So you can see that we have a lot of attributes animated at the same time. And if you have to change the cycle and everything, because it's all procedural, so it could be pretty clean if you have to change anything here. So remember that after we have all the points and I split them into different fish, and then so what I tend to do is I'm gonna render the bright group as a AOV. So instead of just like how we do AOVs for regular geometries, you know, you plug in a parameter inside the shader and set it up in the mentor node. What I tend to do for volumes is I prefer to actually render a separate volume because I still want to preserve the same density. So I'm just going to render a same density volume with a color of white and black. So for example, for fish one here, what we can do is I'm going to drop a point wrangle here. And then I'm just going to plug it in. And here I'm going to use the bright group, the point group. Okay, and then I'm going to do intensity equals to 1. And then I'm going to do intensity multiply equals to channel decay. And then for the decay, let's just plug in what we just did. So let's do point channel anim 0, decay intensity 0, and then here it's reducing. All right, let's create another point angle, and let's just do color equals to set intensity. Okay, and then you can see that we're getting this mask going on the fish. And you probably noticed that I didn't really delete the black points, and that's because I kind of want them to serve as like a holdout as well, because some of the points are actually behind, and I want the black points to kind of cover these as well. And then we can basically just copy paste the VDB from particle, this one we use. So the setting was just same voxel size and density, and then we use the color to create another volume. And then we will set up a separate render node and a different mantra as well. So this one, I'm going to call this box underscore AOV. But the shader will be the same because the shader will pick up the same density for this one. And it's just a white and 2 black color. And then we're going to use these in comp. So here's the result we have here. So you can see that we have this light traveling along the body of the fish. So in the next video, we'll take a look at how we can add some particle simulation on top of these. In the previous videos, we created some secondary animations for the fish. Now let's add some particle sim on the top. So here, this is after the fish animation of one fish here. So let's add a trail node. So let's put compute velocity, because this thing is constant poly count, so we don't have to do any kind of match for attribute or anything. And now let's isolate some areas to scatter the particles. So the idea is whenever the fish is doing the pulsing animation, I wanted some particles to coming from the edge of the fin and the tail. So let's say a split here. So let's put tail here because we had a tail group. And then it's kind of missing this area as well. So let's isolate that area here. So let's put a null. And then let's just double click this area and then just blast. Delete and unselected. All right. So let's grab the part where we just grab part of the animation here. So let's just copy, paste here, and then let's do a copy, paste relative reference. So we want to just isolate the stuff we want from the beginning. And let's put another delete here because I want it to get rid of all the points when the fish is going in and going out of the frame. So what am I going to do is I'm going to put a delete by expression. So if remember the attribute we did on the channel anim, if the reveal attribute is larger than -0.2, I want everything to be deleted. So I only want it to scatter after it comes out of that stage. All right, so let's put a scatter now. So we're gonna use the density scale, let's put 1000. And then let's put a density attribute. So here I'm going to put grayscale, something we did earlier. And then, so this way that, and then we need a seed as well. So we don't want the source to look like exactly the same. So let's put $FF as well. So it's going to grab the color as well. So when we emit this thing, it's going to inherit the same color. And we only want it to start emitting maybe 1 or 2 frames, right, when the pulsing animation starts. So we need to take a look at the chops again. So let's go back to the chops, motion effects. So we can hide these for now. So all we can use is, so if you go back to somewhere here, so this is the first trigger we had. We can basically just export this. So at this frame, it's gonna emit the particles. So let's just put a now here and just put it here. And then let's just rename this. So for now, this is called ramp 0. So let's just rename this emit star. And let's just put this in the merge. So let's just add the attribute here called emit. And then we're going to put it in the channel atom as well. So it depends, you know, sometimes you probably want to do 1 frame emission. Sometimes you probably want to do more. So you can definitely come back and do another trigger, and you can, you know, do a different longer emission animation. Okay, so here let's do another delete. So let's do points, and here delete by expression. So we're gonna do point, channel atom, emit 0. So let's do delete non-selected. So if this is the value is almost 1, then we keep the points. So let's put it on one of the frame that has some source. So for example, 1081, and let's do some cleaning up here. So usually I like to do an attribute delete. So here, let's get rid of some of the attribute we don't need. So we need color, we don't need normal, we don't need UV, we don't need, we're gonna keep velocity. Let's get rid of class, and let's get rid of grayscale. Let's keep the rest. Wire capture, we don't need it either. These, okay. All right, and then let's put a group delete. So I'm just gonna delete any of the groups. So now I'm gonna cache the source out and pause the recording. Okay, so I finished caching the source. Now I'm gonna copy paste the animation curve I had earlier and put it after the source here. And then now we don't really need one of the node, this one, because this node is basically like grabbing part of the animation. We don't need this. And now let's take a look at this whole thing here. So let's pick one frame that there's something. All right, so this frame here, we have something going on. And let's actually create a visualize, and we just turn on the V. So you can create the V here. So basically put V on everything here. So let me just get rid of this. So sometimes if you want to see, like, for example, how far it travels in one frame, what you can do is you can put the length scale to 0.041 instead of 1. So this value is basically 1 divided by 24. So this is how far it travels in one frame. But for now, let's just keep it like this. So if you look at the fish itself, it's here, and then you can see the velocity are actually following this, but we want the velocity to go opposite. So let's put it point angle here. And let's just do v multiply equals to -1. So let's just reverse this. And now let's drop a dot network. So let's just turn off the V for now. All right. Let's just call this dot trail. Let's go inside. So let's put a pop server. Let's plug a pop object to the left. And we need a pop source on the right. And then let's drop a pop force here. And let's drop a pop drag as well. All right, so let's take a look at the pop force first. So we're going to use all points, and we're going to use first context geometry, and then under the attribute, let's just put half the velocity for now. Okay, and then the pop force, let's put force, put like a force that goes up, 0.2. And then let's put a little bit of noise here as well. So let's put D5, and then let's put a swirl size, 0.25. And then let's kind of want this offset to travel a bit. Something like this. So we kind of want each particle to have a little bit different amount of noise. So let's use expression here. And so here, let's just do flow multiply equals to fit 0 to 1 random ID multiply plus. So the range we're gonna do 0.7 to 1.3. And then we're gonna use amplitude to multiply the multiply. Okay. And then in the drag, let's just put 0.1, just a little bit. And let's go outside. So I'm gonna do a sim right now. It's gonna be pretty fast actually. Okay, so this is something we have. It looks okay so far, but the animation I have in my mind is when the fish does this pulsing, I actually want the particle to have like a pulsing towards the opposite direction instead of just like this kind of noise pattern. So let's go ahead and do a customized velocity field for this. So let's close this. So let's go back to before we even start this animation. So let's go back to here when we just isolate the body area. So let's put a delete note here. So let's do points, and then we're going to use the normal. So I'm going to do Z direction and 85. Okay. And let's copy this. So this is going to be -1. And then let's copy, paste the square angle as well. So it's just going to leave this thin area. And if you take a look at the normal here, you can see that it's most of them are okay. Some of the area have problems, but for now, let's just do a point angle. So let's do a V equals to normal. And let's put a point replicate, because the points here, it's really not enough. So the quantity, let's put 3 per point. And the shape, let's put sphere. And let's do like a 0.21, something like this. So it's really smaller. And then for the attributes, let's just do copy source attributes. So now if you take a look at the normal, you can see that the normal just got lost here. And so let's write a wrangle here and to create like a velocity field that we want. So let's put a point wrangle here. Because we lost the normal, but if you take a look at the velocity, it's kind of following the original normal we had. So let's use that here. So let's put the V back to the normal. So let's grab the direction and the length of the normal. So let's create a vector called direction. And so let's just normalize the vector. And then let's grab the length as well. So length equals to length. And then, so we kind of want to, so currently if you take a look at the normal here, remember we actually had a force going on for everything. And because I kind of want the whole thing to look a little bit like actually underwater, so I want the particles kind of go up as well. So I kind of wanted these normals that goes down to kind of mix with the up vector. So everything kind of goes up. So here, let's create a vector called up. So this is going to be 0, 1, 0. And then, so let's set the normal as, so we still want the original length there to multiply. So here we need, so let's just lerp the original direction of the normal with the up vector. And then here we're going to put a mix. And then also because the length is here, so we need to normalize this thing. That. Okay. All right. So let's put something like, so you can see that this way it's going up. So I'm going to put something like this. Just a little bit. So I kind of want the force to be the strongest when the particles are emitted and then gradually reduce to 0. So let's go back to ChopNet and do a fade off for the velocity. So let's turn on the motion effects. So we can grab the second trigger node here. Let's copy that. And then paste it here. And then we don't need the 72. So what we're going to do here is, so under the sustain, let's do a decay length of 3. So you have to kind of do a few tests. So maybe, you know, it needs to be 5 frames or something, or longer or shorter. So let's just rename this. And let's rename this to Vel. And then plug it in. And let's go outside. So we're going to add a attribute here. Called Vel. And then we're going to use the channel to grab the Vel. Okay. And then let's go back to the wrangle node we just had. So back here. So I'm going to do normal multiply equals to channel fade. And the fade value is going to be the channel anim 0 Vel 0. All right. So now we have the points that we want. And now we can, let's see. All right, so we can do a VDB from particles. So let's do a, let's copy and paste it to the scale and use to multiply the size. We're going to use 0.05, and then we're going to do a let's add a attribute here. So we're going to use the normal and the velocity as the velocity VDB. So the reason I'm keeping the density is just because I want to kind of review this thing. So what we can do is, if you want to review how it looks like, we can drop a volume trail. Volume trail. And just plug the first one in with the points, and the second one as the volume. So you can see, so if you turn off the detect range, you can actually see the fade over time as well. But if you keep it, it's just gonna scale over time. So once we have a velocity volume here, I'm just gonna go ahead and grab one of these animation blocks, put it after this, and then I'm gonna plug this in. And then at the end, I'm gonna do a VDB combine. So let's just cook this one for now. All right, so group A, I'm gonna put the density and velocity, and then here I'm gonna choose flatten A groups, and then operation I'm gonna do add. So this way we end up having just one density and one velocity. So you can do another volume trail if you wanna view the velocity field, but for now I'm just gonna put a blast node here. And I'm only gonna keep velocity, so delete non-selected. So it's only the velocity here. All right, and then I'm gonna put a now node here. Let's just call this into dop vel. And then what I'm going to do is I'm going to go back to the dot network. So here, so I'm going to put a pop effect by volume. And so here, I'm just going to plug in the into dot bell here. And then the velocity scale for now, I'm just going to put 4 for now. And then, so you want to use the update force and treat and wind, because when you use the update velocity, it gets jitter a little bit sometimes. And then the advection method, I'm going to do trace RK4. Okay, so I'm going to resim this thing again. Okay, so this is something that we end up having here. So it kind of works like what I expected. And here, this part, we can just kill them by using the age later. So let's continue in the next video to complete this particle simulation. In the previous video, we started this particle animation. Now let's finish this. So I already cached out these points after the simulation. So let's do a few cleanup work. So let's put a attribute delete. So we're gonna get rid of all the attributes from the sim. And then we're gonna keep a few here. So we're gonna keep age, we're gonna keep color, we're gonna keep the ID, and we're gonna keep the velocity as well. And then let's drop a group delete as well. So let's just kill every group. All right. So we only have these attributes. Okay. Now let's drop a point wrangle so this is like a starting preparation. So we're just gonna do normal equals to set 0, 0, 0, 1. Set 0, 1, 0. So this is just generic preparation before you copy things on top of the points. So let's work on the age of the particles a little bit. Let's put a point bob here. Now let's go inside. So we kept the ID attribute. Let's put a integer to float. And let's put a multiply add constant. So here, just put whatever seed you want for these. All right, and then let's do a random. And let's put a fit range here. So from 0 to 1 to, so let's promote the minimum and the maximum. And let's call this minimum life. So minimum life. And then here it's gonna be called max life. Max life. All right. And then we're gonna use the age to be divided by the life here. So we already have the age here, so let's drop a divide. Put that in, and then divide it by life. Now let's just clamp this thing between 0 to 1. And then let's actually export the age as well. So let's put a parameter here, call this age. We're just going to cover the original age. Export when import is connected, invisible. All right. And then here, let's put a ramp parameter here. So we're going to use this to remap the color and the alpha. So let's call this age ramp. Age ramp. spline ramp, cameo ramp. Okay, and then so we're gonna work on both color and the alpha. So let's work on the color first. So let's do a fit range. So again, this is 0 to 1. So let's promote these. So this one we're gonna call this minimum mul, which means minimum multiply. Actually, let me do this again. All right. So minimum mul, minimum multiply. And this one is the maximal. So maximum multiply. And then we're just gonna put a multiply here and plug the color into this. And then plug the second input with this one here. And then just plug the final result to color. All right, so this is the color. And now let's work on the alpha here. So again, we're gonna do another fit range. So let's put the age ramp here. So from 0 to 1 to, let's promote these. So this is minimum alpha, minimum alpha, and then maximum alpha, max alpha. And then let's put a parameter here. And here the attribute is called alpha. So just make sure it's capital A, because that's usually how this attribute works. Export when input is connected, invisible. All right, so let's go outside and tweak all these stuff. So what you can do here is you can kind of see like how long you want this animation to be. So let's say, for example, I want the minimum life to be 1.5 seconds. So what I would do is I could do like a 36 divided by 24, something like that. And then let's just copy and paste relative reference. And here we're just gonna do, let's say, like a 1.3 multiply this. Okay. So you can kind of see like how many frames you want this thing to happen. And so if let's put these in here. So when you want to see how the alpha actually looks like, what you can do is so I often go to the geometry and use the display particles as I usually use disk. So when you use disk, you can kind of see the P scale and the alpha, and that kind of helps me. So I'm gonna put these in. And for now, it's there's nothing in it because we have to tweak the age ramp to be something like this. So at the beginning, we want everything to be, the color is stronger and the alpha is a higher value as well. Just get rid of that one. Okay. All right, so we kind of want this to be smooth, something like this. Okay. So something like this. And we're not going to change the P scale for this case because my idea is I kind of want these to look like little pixels flying away. So I didn't want the pixel to be scaled. I just wanted to just disappear. That's all. And the color at the beginning, let's just do like so minimum 0, maximum let's just do 2. So it's brighter. So you might have to go back and change this once you get a render going on. And the alpha, this is fine. Okay. So, so let's put another blast here. So let's just say we're going to delete anything that has an age larger than 0.95. So we don't have to have like too many points going on. So now we have all the attributes ready. Now let's copy paste these things, use these points to copy some pixels. So let's create a little box here. And polygon, that's fine. So I'm just gonna copy, paste the size of it. All right, and then here, it's definitely too big. So let's go for something like the size. All right, and then we kind of want just the wireframe of this. So let's do a wireframe. Okay. So for the wireframe, well, the radius, let's use, let's just copy this value here and then paste relative reference. And let's say we want this to be divided by, let's say 50. Okay. And we don't want the round corners because this is so tiny, there's really no point. Okay, so you can see that we have some tubes. So for now, what we can do is you can pack this. So it's going to be faster. So let's just pack this thing. And then let's do a copy 2 points. 2 points. Oops. So this is the first, second. All right. Okay, so I'm gonna unpack this for now. And then I'm gonna just transfer all the attribute because I kind of want to see how it looks like. So you might want to go ahead and go to scene and then maybe turn on the anti-aliasing. So let's find a frame that's at the beginning, somewhere here. Okay, let's turn on the camera. So we get something like this. And let's actually just convert this to polygons. So we get something like this. All right. And now we can do some attribute and group cleanup, and we can basically just render this thing out. So the way we render this, the shader we're going to use is exactly the same as the one we use for the contour. And the mentor node is the same. Just make sure that when you render, make sure to turn on the velocity blur because we do have the velocity in the particles. So it's copied onto the little cubes. So you might want to have the render ready and then you can comp this on top of the fish and maybe you might realize that we're having too many particles, too few, the cubes are too big, too small, it disappeared too fast, too slow. So there might be some tweaking that are required. Now I have this set up, I'm just gonna copy paste it. Remember we actually had an edge group when the fish coming inside and outside the frame. So I'm gonna isolate that group and I'm gonna use this to create a particle simulation. So we have just way too many points. So here I'm using the random function to get rid of most of the points. And then you kind of want to use the time shift to shift the sim earlier a little bit because the emission takes some time. So maybe you want to shift like 2 or 3 frames. And now I'm going to plug this in the simulation and we don't need the pop event by volumes. So here I'm just tweaking some of the settings of the force. So instead of multiplying to all the amplitude, so I'm just multiplying to the force, so it has like a fade off at the beginning of the emission. And now I'm going to cache everything out, and we can get rid of some of the particles if you think the amount is still too much. And now we can copy paste it to the box again. So this is the final result we have for the second particle simulation, because this is combined with the animation, so it's kind of covered up a little bit, but you can kind of see what's going on. Now we finished all the stuff we need to do inside sub level. It's time to render everything out. In the next video, we'll take a look at how we can comp everything in COPS. In the previous videos, we finished everything we need to do under SOPs. Now it's time to have all the renders and comp them under COPS, or images, which is the new name for COPS. So let's get started. So let's drop a image network and call this comp. So you're probably used to working with Nuke at work environment, but under COPS, Houdini can actually do a pretty robust comp as well. So let's go inside and let's drop a file node. So let's start one by one to grab all the renders we have. So the first one is, let's go under the render node. And then let's grab the first one, the text box. All right, so I'm gonna pause and grab all the files. All right, so I have all the renders ready. So this one is the text 1, this is text 2, and these are the fish. So let's get started. So in COPS, what we can do instead of merge under Nuke is we can use the add. And it's basically the same. So let's tweak it a little bit, something like that. And then, so for oftentimes when we work on stuff like these, for like holographic stuff, you kind of want to glow the things up. And if you're used to work with Nuke at studios, you probably use the exponential glow. But we don't have that kind of node under COPS, but we can build one real quick. So let's see how we can do a exponential glow. So let's put, so let's work on this one. So let's put a null node here, plug this in. So let's put a glow, the Luma key node here. So under the Luma key, I'm going to turn off the max luminance, and I'm going to shrink the minimum luminance to something like this. And then I'm going to uncheck the discard key region. So what this does is it's going to only keep the highlighted area. So you can change the row off region as well. Maybe something like this. And then we can just glow this area, because essentially what exponential glow does is it just glows the area that's the brightest. So let's put a bright node here. Let's plug that in, and let's change brightness to something like 10. Okay, and now let's drop a blur node. So let's do something like 30. All right, and then let's do a add node here. And then put the original one on the B, and then the blur on A. And let's not add so much glow on it, because otherwise it's kind of blurred as well. So let's just add something around like 0.2. And then let's just put a now node again. And then here, let's just call this out. And then we can plug that to the add node here. So what I like to do a lot is I like to just select all these nodes and then do action, action, collapse to subnet. And then we can go inside here. You can change the name of these. And then let's just call this one EXP Glow 1. Let's just color that a little bit. And you can even go inside and promote some of the attributes that you know you're going to use and put them outside here. So we have our own exponential glow node. But for now, I'm just going to leave it like that. So I'm going to copy, paste this to this one as well. Apparently, this is definitely too strong. So let's go inside. So let's change this a little bit and roll off area. That's fine. The brightness is definitely too high. And the blur, let's see, this is fine. Okay. And we just need maybe less glow, something like this. All right. So compared to before, all right. And another thing that I like to do a lot when I'm working on these kind of cyberpunk projects is I like to add a little bit chromatic aberration. So let's see what we can do with that. Again, we're going to work on some nodes and collapse them into a subnet. So let's put a null node here and just call this in. And then let's put a channel copy node here. So we're going to do target C, and then the source is going to be input C green. So we're just gonna grab the green channel of this. And then let's do another node here. And this one is gonna be the blue channel. So you can rename these CG, and this is CB. Okay, and then let's put a transform node after these two. So for these two, what I like to do a lot is, so let's collapse these for now. Action, collapse to subnet, and I'm gonna call this chromatic aberration 1. And then I'm gonna go to edit parameter interface, and then I'm gonna get rid of these invisible, and then I'm gonna put a float here, another float here. So the first one is gonna be let's just put G underscore offset. So this is gonna be green offset, and this one is gonna be B offset, blue offset. So the range, we're just gonna do 0 to 1. And then this one, we're gonna do 0 to 1 as well. All right. And then, so what I'm gonna do is I'm gonna move the green offset just 1%, and the blue offset to be -1%. So let's copy parameter and go back here and go to the transform. So I'm gonna put under the scale. So I'm gonna do 1 plus paste relative reference, and then I'm gonna copy this and paste to the Y. So same thing here for the blue transform. So we're just gonna use the B offset, and then copy parameter, paste relative reference. And now let's do a channel copy here. So the first input needs to be the original image, and we plug the first transform into the second channel copy input. So this time we're gonna do the target is the sea green of the current image, the input, and then the source needs to be the second input color. Okay, and then we're gonna repeat that. So let's just copy and plug the second one into the second transform, and then this time we're gonna do this target is gonna be C.B, and then the transform. Okay, and now let's drop a now node here. Call this out, and then we're gonna use this as the output. Okay, so we go outside, and if you can kind of see what is going on when we're doing this chromatic aberration here. Okay. And if you want to do any kind of color correct or anything, so here there's a lot of things you can do. For example, you can do color correct. You can do gamma, and you can do HSV. You can just change the hue, saturation stuff as well. And you can do limit, which is basically like a clamp. So all kinds of stuff that you can use, and bright as well. We just use this one, and also you can use the Luma key to select the area that's really bright, and you can do something with it. But usually I just use the color correct node, so you can just plug it in, and I just like to use the mult, something like this, so you can kind of do like a CC work here. So now I'm just gonna spend some time to use the node we just covered and put together the renders of the text 1 and text 2. So using the nodes we just covered, I come up with something like this. So the only part that I did that really needs to mention is for the fog part, I kind of add a lot of chromatic aberration, because I kind of like how it looks like when I add a lot value. So you can see that this value is pretty high, 5% and -3% compared to what I did for these, usually like 1%. But I kind of like the look of this. So now let's take a look at the fish part. So for the volumes, this is the volume render we have. And then I also rendered a AOV, or we call another volume, for the parts that when the fish is swimming, and then there's like a color. You can see that when the fish is swimming, there's like a lighter area that travels along the body. So we're gonna use this as a mask to color correct this part. So let's put a null node here, and then let's put another null node on the AOVs, and then let's drop a color correct node here, and the here the mask input, we need to use the second one. And we do need to go to the mask here and change it to color. And then let's try to increase the value here. So let's do something like, usually I like to do copy paste relative preference. So this way I can actually punch numbers instead of dragging. Okay, so you can see that this is not doing much, because the mask we have, this is probably, the value is probably not high enough. So let's just copy the color correct node, and we just so what I would do is I would actually increase the mask color as well. So this one we don't need any mask. All right. And then let's get a frame like, okay, somewhere down here. And then you can put a now node to as an out, and let's just collapse these. Collapse to subnet, and I'm just gonna call this. Actually, this needs to be the output. So I'm just gonna call this bright AOV CC. And then you can do all the stuff we just did, the exponential glow, chromatic aberration. And so you want to add these on top as well, the trails, the contours, the review animation. So I'm going to spend some time and add these together and maybe tweaking with the text here as well. Okay, so this is something that I end up having here. So I just used all those nodes, nothing really special here. The only thing I did really was, because the whole thing is pretty bright, so I kind of just did some color correct to reduce the value of the background elements. So once you're happy about everything, what we can do is, so here let's drop a ROP file output. And then let's set the frame range start to F end. And here you can do, again, let's get rid of the hip name. So we're going to call this operator. And then probably version 1. And then you can put the version 1 here as well. Okay, so you can use, you can certainly use the EXR, but a lot of time I find that I prefer to use JPEG actually, because if you use JPEG and you can just export a video from and play a lot easier, and this is smaller as well. Another thing I wanted to add was because I want the background to have like an intensity change over time. So I put a color correct node here, and under the multiply, I put a noise here and fit it to 2/3 to 1. So this way you can have like an intensity change for the background. You can certainly go back and add this to all the elements we had, but for now, I'm just gonna export the comp. So this is the final look of our hologram effect, and that concludes the whole training. Thank you again for watching.